Alright, Mr. Day, this is my rockets screencast. So I originally did the worksheet on 2 pieces of paper, and then I scanned them into my computer, so this is how I'm explaining it. So the first question is sketch the diagrams of the situations for the rockets. So here they're on the ground. I use up in my positive direction and down is my negative for all four. You have the low, middle, high, and the super high. And so here it is just smaller, and they progressively go higher, and they all at 0 seconds they all have 0 velocity and 0 position because they're all on the ground. Alright, velocity graphs and acceleration graphs number 2. So here I also made position graphs. So here are the position graphs because it's accelerating up, well, it's constant acceleration, negative acceleration. But so it's slowing down in the positive direction and then speeding up downward in the negative direction for all four, and they just progressively get higher. So all of them have the acceleration of Earth's gravity field, which is negative 10 meters per second. And so the low one I timed out at 3.4 seconds, the medium at 4 seconds, the high at 5 seconds, and the super at 5.6 seconds. So number 3 is what are the change in velocity. So the change in velocity is going to be the area of your velocity. Change in velocity is going to be the area of your acceleration graph. So for the low one, you have 3.4 seconds times 10 meters per second, negative 10 meters per second, which gives you negative 34 meters per second, is your change from here to here. And then the change for 4 seconds is for the medium rocket is negative 40 meters per second. The change for your high is negative 50 meters per second, and the change for your super high is negative 56 meters per second. How fast was each rocket traveling when you launched? So since you have constant acceleration throughout the whole movement of all the rockets, on each side of the velocity graph, they'll have opposite y coordinates or vertical coordinates. So like for since your change is negative 34, if you divide negative 34 by, or if you divide 34 by 2, it's 17. So you start 17 up, and then on the way up it changed from 17 to 0 meters per second, and then on the way back down it went from 0 to negative 17 meters per second. So your launch speed here was 17 meters per second. Then your launch speed, and then for the medium it was 20 meters per second. For the high it was 25 meters per second. And for your super it was 28 meters per second. Number 5. The speed of the rocket is when right before it hits the ground is the same as when it's launched, because they have constant acceleration. So like if you split the acceleration graph in half, it'll be the same as when you cut the velocity graph in half right at the point where it's 0 meters per second. So they accelerate, the length on each side of the velocity graph is the same. So it's just a negative, the speed right before it lands, just the negative version of when it started. Number 6, what is the maximum height of the rockets? So the maximum height of the rockets is the area of the first triangle of the velocity graphs. So it's going to be 17 times 3.4 divided by 2. So it's going to be the first triangles of all of these. So it's for the first one it's 28.9 meters at the peak. Second one is 40 meters at the peak. Third, the high is 62.5 meters at the peak, and the super high is 78.6 meters at its peak. Hold on. Number 7, was the acceleration different when the rocket reached its maximum height? Even though when it reaches its maximum height, it has a velocity of 0 because it stops and then falls back down to the earth, the acceleration is still a constant negative, that's supposed to be negative 10 meters per second squared, because that's just how Earth's gravity field acts on everything all the time. 8, what is the total distance traveled by the rocket? So the total distance traveled by the rocket is when you add these when you add the whole velocity graph without the negative sign. So the total distance traveled. So, Mr. Day, please ignore these numbers. I did some incorrect calculations before I scanned my thing. The actual total distance traveled will be twice of what the maximums are, the maximum height, these. So your low total distance traveled is 57.8 meters. Your medium is 80. Your high is 125 meters. And your super is 156.8. 9, what are the total displacements of the rocket? So all the rockets have a displacement of 0 because they were all launched from the ground and they all landed at the ground 0. So their total position shift in the end was 0. And the answers are different for the last two questions because your total distance traveled is how far it went up and down, which is double the maximum height. But your displacement is the distance between you starting at any position, which was 0 because they both ended on the ground, started and ended on the ground.